So we are now on part C, and it says the first part, draw the efficient frontier. And she has given us, note the portfolio weights should range from 0 to 1 by an increment of 0.1. So that basically means that we have to put the weights at an increment. So we start 1, 0.9, 0.8, 0.7. The difference between them needs to be 0.1. If she says increment of 0.2, then it will be 1, 0.8, 0.6, 0.4, 0.2, 0. So pay attention to the increment you are given. So now, in order to draw the efficient frontier, we need to calculate the portfolio weight and then the expected returns of each, then the sigma. So we are going to start with the portfolio weights. So as you can see, we have 1, 0.9, we have all the values here. In order to calculate the returns for each, we first have to multiply the first weight by the mean of rows, then the second weight by the mean of thorn. So it will be 0 times 12 and then 1 times 5.8. Always remember that this value and that value have to add up to 1. So if you have 0.1 here, it needs to be 0.9 there. If you have 0.2, it needs to be 0.8. So this is how we break it down, and that gives you the returns for each. Now we move on to the more difficult part, which is the sigma. And you're wondering, how on earth do we calculate the sigma? We need to use this formula, which is given to us in the book. So it is the square root of, let's say, the weight. We have two projects, x and y. So it will be the square of the weight of x times the standard deviation of x plus the square of the weight of y times standard deviation of y plus 2 times the weight of x, weight of y, times the coefficient of correlation. Always remember this p here means coefficient of correlation, which you would have calculated in the table. Then here, we've simplified this formula. Instead of multiplying the standard deviation of x by standard deviation of y, you just multiply it by the covariance. So always remember this bit at the end is the covariance. So now we are going to start with our first figure here. So the weight of x in this case will be, we start with 0. Then we have the standard, and that will be squared. Then we have the standard deviation squared. Now from our table, the standard deviation here was 5.66 for rows. So that will be 5.66 squared. Now we move to the 1%, which is the weight of thorn squared times the square of the standard deviation of thorn, which you remember here to be the 4.18252. Then we add 2, and then we multiply it by both weights, so 0 times 1, times the coefficient of correlation. Always remember at the end. So that will be 16. Always remember to calculate them in separate components so you don't get confused. So you do this value first, so that gives 0. Multiply this value first, second, so you keep them all separate. Then at the end, you add them all up. Then don't forget to find the square root. So in the first instance, the square root will be 4.12. So that will be our first value of sigma here. And you do the same for all these weights, so it can be time consuming. But all you need to basically remember is keep the same formula as the first weight, the first set of weights, but you just need to change the weights. So whereas here was 0, when you move next, it becomes 0.1. Where it was 1, it becomes 0.9. Those are the only values you need to change in these equations. So now moving on to the next one, we've gone from 0.1 to 0.2, change the 0.9 to 0.8. So that is all you need to do for all the formulas. Just change the weights. So 0.2, 0.3, 0.4, and just change the weights accordingly. Then that should give you these figures of sigma here. And it should make it fairly simple. So now we would have in one column the standard deviation, the returns, and then here we would have the sigma. So now we go back to the question, and it says draw the efficient frontier. So now always remember, to draw the efficient frontier, you need to plot the return on the vertical axis, and then the sigma on the x-axis. So if we look at our values, we would have 5.8 against 4.12. So you know that 5.8 will be on the vertical axis. So we'll find 5.8 here. Then we have 4.12, so you just follow along on the line. And then that helps you to plot your first step. Now you move to the second, so 6.42 and 4.12. So you go back to vertical axis, 6.42, follow the dots and go to 4.12, and then plot all your values. Always remember returns on vertical axis and the sigma on the horizontal axis. And then you join them all up, and that gives you the efficient frontier. So all in all, you've answered the first part of the question, which says draw the efficient frontier. Now the remaining part of that question is discuss the composition of optimal portfolio when there is no risk-free assets. You've been given a formula over here, so you just have to look at that formula. It's fairly simple, so we are going to go through that in a second. So this is the formula, and basically, so if you are calculating the percentage of composition of the portfolio, it basically means what's the percentage of that project or that company in the optimal portfolio. So to calculate that of X, you need to have the standard deviation of Y squared. And remember from the formula we did earlier, this is simply the covariance. So don't worry yourself too much with this formula here. And then at the bottom will be standard deviation squared of X, company X, standard deviation squared of company Y, minus 2 into brackets the covariance. So always remember this value here is the covariance. That's the same as the coefficient of correlation, and then multiplied by these values here. So now we look back at our table, and we see that the standard deviation squared of Y, so that would be 4.118 squared. So that gives us 16.6. We know our covariance is 16, so we subtract it. And then at the base as well, so it will be 5.66 squared, and then plus 4.118 squared, minus 2 into bracket the covariance. And that gives you this figure here. So that would be 0.96 divided by 16.98. And that gives you 0.056, which is the same as 5.6%. Notice that she asks us to the nearest percentage, so which means you need to round it up. So since 5.6 is closer to 6, we can say that it will be 6%. So it should be 6% of the entire portfolio, which is 100%. So we need to subtract 6% from 100, and that will give us 94%. So you can see here that the composition of the optimal portfolios are: Rose is equal to 6%, and Thorn is equal to 94%. And that is how you answer the question. Thank you.